All right, so yeah, Jeremy Alons, work for Spot Trading. So Spot Trading is a proprietary trading firm. That just means that we have no clients. We are entirely self-contained. So this talk is a case study in continuous delivery. So I guess, hold on, I gotta find my slides. There we are. So Spot Trading, again, proprietary trading firm, active in multiple markets, including cash, options, futures, other derivatives. Basically what we do is we price, inventory, and provide risk in the markets. That's kind of our plane, which if you're not in finance, that means absolutely nothing to you. But I mean, that's as obvious as I can go, so it is what it is. So we're going to talk about a case study into continuous delivery. So why? Well, before we can go into the why we wanted to automate our deployments, I got to kind of tell you where we came from. Previously deployments, they were all manual. They were very time consuming. It sometimes took weeks to actually push out any one application, which is pathetic and terrible. And manual processes meant, there's a lot of manual places for failures. So we set about this automated deployment pipeline, this goal. We had a couple of ideas in mind, what we wanted. We needed rapid feedback. We couldn't be waiting a week to make sure that we had just pushed off the latest software that's talking to an exchange. That's just way too long of a lead time. We wanted to make sure we tied configuration to our deployments. Highly parallelizable was nice. We don't have thousands of servers we're deploying to at one time, but if we are deploying to 10 servers, we would prefer those 10 servers get code at the same time, not serially. And we wanted to treat our infrastructure as code, the DevOps mantra, et cetera, yada, yada, yada. But the main three things for what we really needed out of this was we needed it to be repeatable, we needed it to be reliable, and we needed to automate as much as is reasonable. Because Spot has a lot of challenges when it comes to software. We ourselves have lots of unique software. We have hundreds and hundreds of applications. The differences in those applications force a lot of complexity. We misuse a lot of the tools. For the first year of running Salt, we didn't write a single state. We used Salt entirely as remote execution for an entire year because we didn't need states. We're smarter than that. Turns out we weren't very smart. We have since remedied our ways, and we're back to writing states now, but yeah. And we needed to write a lot of additional tooling because for what we do, there wasn't a lot of, there's no system D for our systems. There's no real way to schedule that, hey, all of our applications that are required to send a quote to the market are available, therefore we can start the application that actually sends a quote to the market. And we also have a lot of industry challenges. Being that we are finance, we have a lot of unique to Spot or unique to finance issues. We make markets in some of the most competitive capital markets in the world. We compete with the big boys. We are a big boy. The U.S. markets are highly geographically dispersed. They're highly fragmented, highly evolving daily. There's not a day that goes by where one of the exchanges isn't changing something, whether it be their protocols, their endpoints, routing networks, all this stuff always changes all the times. We have to process massive amounts of data in real time, evaluate complex derivatives. That just means compute whether or not this is a good deal or not, and then decide whether or not we want to make the offer to buy that. Every time a tick comes in, every time someone else buys a stock, we have to respond to that and say, well, is it still a good idea to buy it? Well, probably not. Well, yeah, maybe. So that's constantly happening millions and millions and millions of times a minute. And the increasing complexity and pace of technological change, yeah, you can read the slides. It's constantly evolving, constantly growing, and constantly scaring us, as there's been a lot of highly publicized failures. NYSE went down for a while, NASDAQ goes down for a while, and everyone freaks out when these guys have their little hiccups. No one gets on the curb and starts writing SEC filings when Google has a hiccup or Netflix stops streaming, but we kind of get looked at a little closer for those types of items. And so in order for us to have to respond to these items where we are under very tight watch, we are very, sorry, I lost my train of thought there. We needed automated deployments to be the cornerstone so we can move quickly and safely handle our software deployments, since there's a lot of opportunity for us to do very bad things very fast. So for software deployments and software development, there's basically 4 steps. We're going to only, there's nothing groundbreaking here, you can break them down farther with tests and all that jazz. All we're going to do is we're going to talk about deploy and config. Yes, those could be combined, whatever, just let's go with it for now. Build is, it's simple, right? It's just Bamboo, it's just steps, just step down. whatever it is, you put stuff in, you get stuff out, right? You check in your code, run, build, get back some kind of an artifact. We have mostly compiled applications at Spot, so we don't have the luxury of doing like a Git-based deployment or similar items, as the size of our binaries are rather large. And so we have that challenges. Well, so now we have our binary. We have our 100 and some meg, 200 meg, whatever the size of this binary is. And now we got to decide what we want to do with it, right? Because just bits don't do much, right? So we need to get the artifacts where they need to go. So in finance, different servers are probably better suited to run applications than others, same as anywhere else, right? You don't want to run your database server on a compute node in AWS, right? You want beefy servers to do beefy tasks. You want non-beefy servers to do non-beefy tasks. But how do you find those servers? So, I mean, what host should these things go to? How do you make sure that when you do push your software that you have the exact right version on each of those servers? You know, these are all just simple questions that you kind of just don't really think about. Well, SaltStack to the rescue. Like I said, remember this was originally geared for a little less experienced audience. So from the website, fast, scalable, flexible systems, management configuration, data center automation, cloud orchestration, server provisioning. Well, we liked this when we read it. We liked data center automation. We really liked configuration, or server provisioning, really liked configuration management. And the more is what really sold us on Salt, right? So before we can really talk about what more you can do with Salt, the stuff that Salt gives you for free, you know, the grains, OS, major, minor, something you can ask a server for, it comes back. We really like pillars. I know some people have been very anti-pillar at this conference. We really like it because it's something we can tell, we control it. You know, grains are something you ask, pillars are something you tell. So you have the ability to basically determine two types of data. Salt is extremely extensible. So that's basically what the more is, right? I mean, there's anything you can do. External pillars are just Python. So if you can do it with Python, you can do it with Salt. So what we did was we wrote an external pillar to interface with Zookeeper for host discovery. So people have their spreadsheets with with server host names to whatever not. We shoved all that data into Zookeeper because why not, you know? So Zookeeper maintains the source of the truth for Spot. So at any given point in time, our Zookeeper trees will tell us exactly what application is running, where it's running, and the specifications for that app. Like, what does it depend on? What time should it be up? Should it shut down right at market close? Should it wait 5 minutes, wait 10? Those types of items. We use Bamboo. We're an Atlassian shop, so we use Bamboo for our build servers, and Bamboo doesn't talk Zookeeper at all. So we just facilitate that communication through Salt. Real simple. This is our current, well, this is not our current, but this is our deployment pipeline path. When we started off down this path, this was basically V1. So we'll step through the slide here really quickly. The top portion is just the developer checks in code, you know, triggers into the stash repo. Stash repo then triggers Bamboo. Hey, go build this. Artifacts result. That's the end of the line. Like that's where that part stops. So at that point, you now have an artifact. You have code that could run, but it's not getting pushed anywhere. At that point, the developer then either manually or automatically says, okay, Bamboo, deploy. Well, like I said, Bamboo doesn't really talk to Zookeeper, so Bamboo has no idea where to deploy to. And so Bamboo reaches out to the Saltmaster. Saltmaster queries the Zookeeper, which then returns a list of minions to target. It then pushes its configuration up to Zoom. Zoom is a custom Spot application that we open sourced that is used to show our application dependencies and application status. So as part of the deployment process, we push up the latest configuration. So that way if a developer decides, hey, I no longer want to depend on this application we're getting rid of, or I want to make sure I get risk data from this new app that we're demoing or whatever, that's all done at deployment time when the developer pushes go. And then finally, the Saltmaster triggers the targeted minions just to run some states, right? That's all there is to it. Bamboo talks Salt via Salt's REST API. We really like the REST API. We abuse it. Like I said, a full year, all we did was talk to the API, and we were happy. Salt talks to Zookeeper via external pillar, and then by transitive property, Bamboo talks to Zookeeper with the added bonus, no Java. So again, Salt asks Zookeeper, what hosts are currently responsible for app foo? Well, how does Salt actually talk to Zookeeper? It turns out this is all it takes to have Salt talk to Zookeeper. That's all there is. So the one part left as an exercise to the home readers is the cache class here. All that does is that's just what spot represents an item as. Cache is just a representation in memory. It's probably not the best name, but it is what it is for showing, excuse me, so for showing internally like how you take a Zookeeper node and then map it into a application representation. So that's all the cache is. But that's all it takes to write an external pillar. So Zookeeper responds. We run a series of state files on those targeted servers. Nothing groundbreaking there either. A couple custom states, assert.py. That way we can actually ask and make sure that if we target a server incorrectly, it can still meet or exceed expectations. Like I said, like if you're going to deploy a database, you don't want to deploy it to AWS extra small instance. You're going to check to make sure memory's okay, make sure there's enough disk space, make sure that it's physical versus virtual, make sure it's in the right data center, make sure it's connected to the right switch stack. All those types of items that might be better for the application that's being deployed or run. Those are all made from custom states that are just checking stuff. Apply anything that's modifiable. Hey, this guy needs 8 megs of UDP buffer, or this guy needs 1 meg because if we ever buffer anything, we've already lost, and so we don't want to make a trade with something that's been sitting in a buffer for the time it takes to read off a meg of data. And those types of items. And then we just install software. Just the equivalent of yum install. Foo release -23-10. That's just something that RPM gives you for free, right? So after we finish building, we put it into an RPM. Why RPM? Well, we wanted to use the tools that are available. Built-in versioning. It's well understood. It's stood the test of time for many years. It allows you to specify versions. It allows you to control what version you're deploying. In latest, N-1, N-2. This is all passed through via pillar, so you can override pillars on the command line, and so that's what we do. We just pass in additional pillar data at deploy time, and then hand that information through. We wrote Airstrike, which is just an API wrapper around that takes Bamboo variable names and translates them into Salt states. So effectively, that's all it really does. We just take these values that Bamboo knows about, like build number, branch, any other type of information it has, and we just change that into a corresponding pillar value or a Salt state. And it's all just pluggable because all it does is just, again, call states, either built-ins or custom states that are written. So when this was the RPM-based deploy state, just set a name, install it, done. Well, I don't know about you guys, but if you've ever actually worked with RPM, it is a terrible experience. They're not great to work with. They can be very, very unforgiving. If you forget to include the changelog item, they will not build. They will fail in weird and spectacular ways. The spec files they're very annoying to automate. We ended up writing more grep and awk than we were actually writing software. Like, it was just terrible trying. And this is just to automatically build an RPM at the end of it. Pop quiz: when does pre-un run versus post? For those that have run RPM-based distros, I don't know. I don't care. I don't want to know. Like, that's just. Anyone would want a Debian-based distro? Maybe. RPMs in Windows? Well. And MSI automation's fun, but that's another talk altogether. And I mean, do your developers really care? Like, do they really want to even be bothered with this question? Do they want to see a deployment fail because the RPM failed to actually build because they listed a file twice in the file section? No. Let's replace them. Why? I mean, it's okay. So let's write a custom deploy state file that now whatever we want. Right? So since it's a custom state, it's written in Python, it's extendable, it's Python, so happy developers because now they can contribute because they can write Python. Happy DevOps because I don't know if you guys have tried, everyone here has tried catching an exception in Bash, and we all know how fun that is. It's a lot better experience. And the really great part about this whole thing is that it was a super minimal change, right? So here's the blown up side, just taking away the dev side, where we have the salt master talking to zookeeper. Zookeeper tells you what host to minion, or what minions to target when we run the deploy state. Well, now instead of running a deploy state, we run a deploy state. That's just a different deploy state. So why push this logic off? Because Bamboo can copy software, right? Bamboo can do software deployments. I mean, well, if you guys have worked with it, it's painful. Is the best word I can say with it. It requires a lot of human interactions. And as we went back, if we go back to our first couple of slides, human interactions can cause two problems, right? Because we've all fat-fingered a number. We've all copied and pasted twice and not realized it. We've all done those weird things. And if you're working in Bamboo, you have these little text boxes that you're pasting into, and it's very hard to work with. So what we do, rather than that, is we actually hand our developers a template. Spot loves templates. And we turn that parsed, we take that configuration and we say, here, developers, explain your system to me. Explain what you need. When do you need it? Where do you want it? What directory on disk do you want this software to live on? Do you have an init script? Hopefully. Do you need anything run beforehand? Like you need it, if you are writing a Python app, do you need a bootstrap run before? All those types of things. So all those items are just options that are in a configuration that lives with the repository of the developer. So we have a lot of repositories. Like every app is in its own standalone repo, so we have hundreds and hundreds of repos. Working in multiple repos is annoying, and so we like to keep things as close to the developers as possible, because ultimately we want our developers to be writing software that makes trades, that makes money, that does what we want it to do. And so we want to keep it as close as we can, so we just grab that config file out during deploy time, keep it as an artifact of the build, and then we parse that config file, we do what the config file tells us, and we just write those bits out to disk. Just talking to the API to actually do all the stuff we need. So it's really quite simple. And I flew through my talk. Oh my God. All right, so things we've learned. In the end, it's all just bits on disk. All software is just software, it should be equal. We like to treat our application that's responsible for sending a quote to the market the same as the one that's reporting on yesterday's trades to everything else. Like everything's equal. Catch issues soon with your deployment process, and you test it early, test it often. Being clever will come back to haunt you. Developers will find fantastic ways to push bits if you don't do it for them. So it's usually better to cut them off and guide them to centralized ways of doing things. If you're not opinionated, you're going to introduce complexity. So internally we're having a good discussion right now about what markup language to use for this config file. Some people hate themselves and want to use XML. Some people want to use YAML, and some people want to use JSON. I'm pretty sure one developer is going to do it in Markdown just to spite me. So now, instead of just saying, okay, here's a nice configuration file that we'll parse, fill it out, and do what you need to do, now we have 4 separate classes for parsing the different languages. And that's just, yes, unit tests should prevent any problems down the road, but now that's something we also have to maintain and keep cognizant of. So the highlights of our deployment process, what we've done, we implemented our deployment pipeline. Everything's now an artifact of the build. We bring components together. I don't remember what that all means. But it is repeatable, and we do get a rapid feedback. There is minimal human interaction. There's as much or as little as you want. You can make it entirely manual if you want. You can just click every button and make sure your deployments go. Or if you trust the system, you can just say, okay, when this build succeeds and passes unit tests, it just gets plucked out to the servers, demarked as staging. We won't allow systems to go past staging. We don't want automated deployments into the markets because that's just probably asking for problems that we don't want. So, but the code's out there that would allow that to happen. So that's kind of scary too. And all deployment changes are code reviewed. So either the developers are code reviewing their own changes, so they're the ones that are changing it, saying, I don't want this to live at /foo. I want to live it at /bar. Great, I don't care. You don't have to talk to me for where you want it to live on disks. The systems are all just systems. Who cares? But the items that actually do the deployment, that's all code reviewed again by the development or the DevOps teams. So we can't actually change how we lay down the code without someone else actually seeing how. So that's all there is. So, yep, that was my talk. So questions? Yes, sir. Okay, so the question was, is the deploy state part of high state or is it one-off? The answer is it depends. We do not currently incorporate the deploy as part of high state for most applications. We've just separated our top.SLS and target based on whether or not we should. So it could be, but we're not there yet, as we like to schedule our high states to run before and after market hours, and we don't. And so we want to make sure that we can deploy software if we need to in the middle of the day without running high state or with run. So effectively, it's just configurable and it's user demand. No, it's the deploy state was written idempotently, so we can run it 1,000 times, and in theory, no changes, pending bugs. I'm a very pessimistic person. Sorry. Yes, sir. Oh, okay.
Well, high state is basically for provisioning and configuring the system, and the deploy state is literally just to drop binaries there.
Yes. Yes. So the question was, is the deploy state effective or high states for provisioning systems, and the deploy state is for moving bits, and that is effectively what it is. As part of the deployment, as part of Airstrike, it does 4 steps. It checks to make sure it can run. It runs high state if it's told to run high state. It deploys the bits on disk, and then it verifies that everything went according to plan. Because even though exit codes and return codes should say that nothing, we don't trust it. Trust but verify is the saying we like to say. We'll still check everything again because there's no harm in checking. Yes, sir.
So what is something that Salt could change or do that would make your life easier?
Question is, what could Salt change or do to make my life easier? The main thing would be performance of the file server. We tried hooking up the Salt file server directly to our data store, and at the time it was something like 4 terabytes, and performance was pretty abysmal since we have several 100,000 directories of different builds, different libraries underneath those builds and everything else, and the performance was just not there. So we've had to actually build our own method for moving bits that we call, effectively bypassing the Salt file server.
So you said that you like Pillar. You guys like Pillar.
Mhm.
I haven't heard much about Pillar. But we use Pillar.
Okay.
The one thing, though, I'm kind of curious, the environment versus role, have you guys run into problems trying to target specific environments? Or do you use the environment as literally in development stage of QA production?
Okay, so I heard 2 questions in there. The first was effectively our take on pillars and why we like them, and the second question was the environment and how those are used at Spot. So for the pillar front, we really like pillars because we like to be able to tell data. Like, we don't want to ask a server, because then you have to wake up and talk to every minion and say, hey server, do you have this? Whereas with a minion, you're just blasting down that data saying, hey minion, you are this. To us, it's a lot more declarative. As for the, what was the other one? The environments. We use 1 master per environment, but we still also do use env equals. It's kind of a fail-safe. Our base is empty on non-prod Salt master, since base maps to master branch. We originally tried to use the getfs for our states. Again, we found our performance to be lacking, and we needed to move to local disk. So now our entire state tree is deployed by a state that just writes out the latest Git repo based on the environment. So the state will clone the staging branch into the staging Salt master. The state will deploy a base or master into production. I would love to move away entirely from it, as it adds a lot of complexity, especially when you start working around the, well, base is master, but master is prod, and the weird naming structure there. But in fact, it just hasn't been worth it for us. So we still eat it. So, yes, sir.
You talked about Zoom.
Yes.
This is an in-house thing that you've open source. Could you describe that a little bit more and talk about how that fits into Zookeeper and
Yeah.
nodes are getting what?
Yeah, so Zoom is Zoom is effectively a front end to Zookeeper. Spot's learning. We're new to the open source world as a fighting back. We're trying to figure out how to do that. Surprise, surprise! If you open source it, they don't come. You actually have to provide an environment around it as well. Zoom is a display for the current status. So it will report to you that if you have applications, I apologize for terms, but foo, bar, and baz. And baz depends on foo and bar. Zoom will represent that and actually show you as a line item saying it can't start because it has not met this dependency. And then it will give you the option to resolve that dependency by either starting the application manually or pointing out to you a best guess of why the application couldn't start. Well, it couldn't start because Quux is down, and there was an unknown dependency of the top two applications. That downstream app was actually a dependency as well. So I would love to actually show a demo, but I can't show server names, and I can't. It's too. One of the reasons why we have not got any real assistance with our open source app is it is extremely complicated to set up, and so I gave it a good hour to try and get a test set up so I could actually show it, and it didn't go well. So we're learning, we're trying. But yeah. So that is effectively what it is. It is a lot like System D or etcd, just something that Spot wrote. And sorry, the question was, what is Zoom and what does it do for us? So any other questions? All right, well, thanks guys, appreciate it.